2 is still comparing speeds. We're still going to use the DRT. We're still going to do boxes, okay? We're going to try our best to imagine what it would be like doing these without a calculator, because remember, these are very likely, we see these on that first part of the test where you have no calculator allowed. So let's jump right in. Okay, number 1, I want you to pay attention to what it tells you, because this time the problems are not like the ones yesterday where they said a phrase. Do you remember the phrase from yesterday? Same distance. Do you remember that? So if that was the case, you were actually trying to find, you were representing the distance, which was rate times time. And the other, if it was a train and a car, that's rate times time. We're not doing that today. We're kind of doing different problems, but we still have distance numbers, time numbers, and rate numbers. First thing I want you to do, guess what? Draw, guess what? Box. So 3 by 2. Okay, draw your box. This box is our organizer. Okay, it's a way for us to get our information in the right place. And of course, the equation is going to be D equals R times T. Put that across the top. Now, what we're going to have to do, part of the challenge for today is we're going to have to change everything to miles, and times are going to be changed to hours. So let's go jot that down right now on the side. Change all to miles, and we're going to change them to hours. And they're going to give you every different combination that's not miles and hours. Okay, like the first one, I see 10,560 feet. Okay, and I don't see hours, I see 30 minutes. But before I can put it in my table, I'm going to have to make sure that I know how to change those over. So we have to have a conversion factor. 1 mile is 5,280 feet. And I'll be honest with you, usually they give you a nice, easy number of miles. Okay? Anybody want to guess how many miles there would be 10,580 for Bart? 2. Even if we double checked it, 5,280, 5,280, 0, 8 and 8, 6, carry 1, 2, 2 is 5, carry, carry 10,560. Does everybody get it? So a lot of times this is going to be an easier number. So when I go ahead, I'll have Bart. So Bart's on my first line. Roger's on my second line. I'm going to summarize their information in 2 different lines. Okay, here we go. We just decided that 5,280 feet is 2 miles. So I'm going to put the 2 for Bart. Now, is that Bart's distance? Is that Bart's rate? Or is that Bart's time? Distance. So this time, I have to put it in the first box. So yesterday's problems, we did not have to use that box. Everybody good? What else did they give me? 30 minutes. I got to change it, though, in perspective to hours. What fraction of an hour is 30 minutes? That's a half an hour. Okay. So is that his rate or his time? That's his time. I'm going to use 1/2. Okay. Now, I do not know his what? Rate. So I'm just going to put an R in here. Everybody good? Now, Roger ran 1 mile. Where does that go? Distance, rate, or time? Distance. And that's already in miles, so I just grab it. 10 minutes. So I have to ask myself, what fraction part of an hour is 10 minutes? 1/6. So I would have to think about that as 10 minutes out of how many minutes? 60. 10 minutes out of 60, and of course 0 can cancel a 0, so I'm left with a fraction of 1/6 of an hour. So 1/6, and that would be his time. What do I not have for Roger? His rate. Now notice the question says, how much faster was Roger? In other words, we're talking about, well, I need to know how fast did Bart run, how fast did Roger run, and once I get those answers, then I'm going to have to say who was faster, how much faster. So what if one of them ran 10 miles an hour, and the other one ran 12 miles an hour? Then you would have to subtract to get 2. Does everybody see what we're getting ready to do? All right, the organizer box is what we're going to use to pull out. I'm going to pull out this entire first level, and I'm going to say that's 2, and 2 would be what? 2 is going to be distance, and it's distance equals. So after the 2, put your what? Equals. Then it's going to be r times what? 1/2. So I'm using my box as my organizer, and it's going to tell me what my equation is going to be. Now, how do I solve for r? Okay, I could divide by half, exactly. Or what's dividing by 2? What's the opposite of divide by 2? Multiply times 2. So I'm going to do that. So I'm going to times this side by 2, and that means 2 over 1. Could you say 2 is the same thing as 2 over 1? Well, if you multiply this side by 2, what are you going to do over here? Multiply that side by 2. 2 on top and bottom cancels. Okay? What's the only thing left on this side? R. 2 times 2 on the other side. So how much rate? What is the rate at which Bart was running? Okay, so Bart's rate is 4. Got him? All right. So we have spent a few minutes talking about, I'm going to multiply by the reciprocal, or basically I've divided by 2. So the opposite of divide by 2 is times by 2, which could be over 1. So times this side by 2. 2's cancel top and bottom because it's like 2 over 2, which is a 1. And I end up with r equals 4. So that's Bart's rate. Okay, now I'm going to grab the equation for Roger. Let's grab the equation for Roger. How would I pull that out? 1 equals r times 1/6. Now, that's really like r times 1 divide by 6. What's the opposite of divide by 6? Multiply times 6. So if I multiply this side by 6, that's 6 over 1. Multiply this side by 6 over 1. The 6's, the 1's cancel. All I get is an r equals, what's 6 over 1 times 1? 6. So Roger was faster, wasn't he? Okay, and the question says, how much faster was Roger? 2. So it'd be 6 minus 4. So he is 2 miles per hour faster. First problem, we have to get used to fractions. We have to get used to organizing it in a box. This time we do have distance, we don't have rate, so we're asked a different question, but we can still organize in the data in the box. Okay, did you get copied down what you needed? Okay, going on to the next one. So we're going to do this we're going to practice several of them, and then we're going to do some classwork. Draw my box. Break it into 3. D equals R times T. At the top, my two things are, looks like Kevin and Rebecca. Kevin, I'll just put for a K, and R, Rebecca. You got yours organized? Every single time, draw the boxes. First question, 15,840 feet. We got to change that to how many miles? Roughly, let's see, 5,000 feet. So that would say roughly 3. I'm going to bet that's 3. Guess what? 3. It is. That's 3 miles. We don't have a calculator to confirm it, but if we added 5,280, 5,280, 5,280 3 times, so the distance that Kevin ran is what? 3 miles. Everybody good? In 30 minutes. That's a half an hour, right? Is that a rate or a time? It's a time, 1/2. I do not know his R, so I'll put an R there. Rebecca ran 1 mile. 5 minutes. That is 1/12. That's 5 minutes out of an hour-long 60 minutes, right? So what fraction is 5/60th? And it does work out to be 1/12. Okay? 1/12 of an hour. Because let me ask you something. Every 5 minutes we get to 1 on the clock, then 5 more minutes we get to 2 on the clock, 5 more minutes we get to what? 3 on the clock. So how many big numbers are on the clock all the way around? 12. Does that make sense? So you got 5, 5, 5. So that's going to be 1/12, and we do not know Rebecca's rate. Now it's basically saying Rebecca was faster, and it's saying how much faster. Do y'all know what to do? Let's pull out Kevin's equation and solve for how fast he was. 3 equals R times 1/2. I'm going to pull out Rebecca's. Rebecca's is 1 equals R times 1/12. Okay, I'm going to do the opposite of my fraction. Dividing by 2, opposite is times by 2 on both sides. How fast is Kevin? His rate is 6. Does everybody see where I'm getting 6? Tell me what Rebecca's rate is. What's the opposite of my fraction? Divided by 12. Opposite of divide by 12 is multiply times 12. Okay. Rebecca's rate is 12. Kevin's rate is 6. She was faster. Now, it says how much faster? 12 minus 6 is what? 6 miles per hour faster. 2 down, 3 or 4 to go, I think. Maybe 4 or 5 to go. What do you think? This is day 2. It's not too bad, is it? But you do have to work with fractions, and you are going to have to change your distances. Okay, again, draw boxes. D equals R times T. It's very important you get the equation up there. Got to work with the right equation. Alex and Sally, so A and S. I'm organizing my data table. What number am I going to put on top for Alex? Give me numbers. Give me numbers. Okay. Caitlin, where would I put a 1? For Alex or Sally? D, R, or T? For D. Alex's D is 1. What do I do with 15 minutes? 15 minutes out of 60 minutes. Is she right? Is it 1/4? So if you go 15 minutes on the clock, you've went 1/4 of the way, right? Then a second 15, a third 15, and then back to the top. I believe she's right. So 1/4. This 1/4 of an hour, that's our time. We don't know his rate. Okay. All right. For Sally. Sally walked 3,520 yards. How many miles is that? Now, this says 1 mile is 1,760 yards. It sounds like 2 miles, right? So if we check 1760 and 1760, 0, 6 and 6, 2, carry a 1, 14, 15, carry a, 3,000. Yep, you're right. 2 miles. So Sally has a 2 here. 20 minutes. Are you sure? 20 minutes. So I would say 20 minutes out of how many? You always compare it to an hour. So the hour has 60 minutes. 20 minutes out of 60 minutes. That's 2 out of 6. It's not 1/4. 2 goes into 2. 2 goes into 2 1 time. 2 goes into 6 how many? 3 times. So it'd be 1/3. R. Okay, I got to use the equation to pull out Alex's to find his information. 1 equals the rate times the time of 1/4. What's the opposite of divide by 4 is a fraction? Multiply by 4 over 1. So multiply this side by 4. So what's the rate for Alex? 4. Okay, next one. Let's pull out Sally's. 2 equals R times 1/3. What's the opposite of divide by 3? Multiply by 3 over 1. Multiply both sides by 3 over 1. So R is equal to 6. Now it did say Sally was faster. How much faster did Sally walk? 2. There we go. 6 minus 4, 2 miles per hour faster. So far so good? We're going to roll. We're going to roll. We're going to roll. Okay. D equals RT. Pialo and Jason. I don't know. Paulo? Paulo? He walked 2 miles in 30 minutes. 2 miles. So this time, 2 miles is my distance. So I'm going to put this in here for distance. We have to change everything to miles and hours. So 30 minutes goes in as what? What fraction of an hour is 30 minutes? It's 1/2 an hour. So that would be his time. I do not know the rate that Paulo was walking. Jason walked 15,840 feet. 15,840 feet. It's about 5,000 for every 1 mile, so 15 would be about 3 miles. Okay, so 3 miles. 40 minutes. Okay, be careful. 40 minutes out of what? Okay, cancel the 0. I end up with 4/6. That does reduce, but without a calculator, do you remember how to do it? 2 will go into 4 how many times? 2 times. 2 goes into 6 how many times? 3 times. That's the first time we've had like a number top and bottom. So this time it's 2/3. I don't know how fast Jason walked, so I just put an R. Everybody okay with what we've done? Do you know how to pull out the equation? Okay, let's go in here. We're going to pull out these numbers. 2 equals R times 1/2. Second equation, I'm going to pull out 3 equals R times 2/3. Solve the easy one first. How do I get rid of 1 divided by 2? Multiply by 2/1. Neat, neat. R is equal to 4. So Paulo is 4. He can walk 4. What about Jason? Okay, this time the R is multiplied times 2. Then it's divided by 3. So I have to do the opposite. So what's the opposite of multiply times 2? Divide by 2. What's the opposite of divide by 3? Multiply, which is my reciprocal. It's when you flip the fraction. Everybody good? So if I flip the fraction, that's going to get rid of the 3 top and bottom. It's going to get rid of the 2's top and bottom. But if I multiply this side by 3/2, I have to multiply this side by, it's going to be what? So 3 times 3, you could always put a 1 under that. 3 times 3 is 9. 2 times 1 is what? So I am going to have a decimal. If you have $9 divided 2 ways, 4.5. So 4.5 is equal to R. Everybody good with that? Now the question says, how much faster did Jason walk? Well, Jason was faster. So it's 4.5 compared to 4. So he was what? 0.5 miles per hour. Okay, did the 3/2, yes sir. Did the, yeah.
My sheet it says how much faster did Paulo walk than Jason.
Then it's probably got fixed and I just didn't fix it. All right, we're going to move on to problem number 5. Is this the same as this is?
You don't have to change it.
This time it says feet and seconds. Most of these are saying miles an hour. So if it doesn't tell me, I'm going to do miles and hours. But in this particular case, what did it say on this problem? In feet per second. So I'm going to change it. I'm going to leave it in feet, and I'm going to change it to seconds. So same boxes. Draw your boxes. You should be getting very much in a habit. I got Tim and I have Jeremy. Tim claims he can run the 100-yard dash. 100 yards, but every yard is how many? So you think of a yardstick, there's 3 feet in a yardstick. So if you have 100 yardsticks, do you add times by 3 or divide by 3? Times by 3. So how many feet would 100 yards be? 300 feet. So it's 300 feet. So when I put that in here, that is the distance. So that's the distance for Tim. So it's 300. Put a 300 in the box. Everybody good with that one? 15 seconds. Do I need to change that? No. 15 seconds is a time, and I do not know the rate that Tim is running. So far, so good? Help me with the next one. Jeremy claims he can run 400 feet. Do I need to change that number? No. This time I want feet and seconds. That's already in feet, so I don't need to change it. That one's going to go in as 400. 10 seconds. Well, I need feet and seconds. I have feet and seconds, so I don't have to change anything. So I do have a little bigger numbers this time. I don't have a fraction. We should be able to work it. How would I get Tim's? Pull out Tim's equation from the top line. 300 equals R times 15. Use this as your blueprint. What would I do to solve for R? Divide by 15. Divide by 15. Now, a lot of times when you have zeros, that's easy. I'm going to hide one of the zeros. What's 30 divided by 15? 2. And then add another 0. So the rate turns out to be what? So he must be running 20 feet per second. What about Jason? Pull out Jason's equation. Can you pull his out and do it? 400 equals what? R times 10. Are you feeling more comfortable working these out with no calculator? You needing it a whole lot? Not as much? Divide by 10. So R is equal to, what's 400 divided by 10? Well, I can cancel a 0 for a 0 and I get 40. So the question says, in feet per second, who is faster and by how much? Okay, right. So Jeremy is faster. And it's 40 minus 20, which is 20 feet per second faster. Yeah, but it's comparing speeds. 20's 40, if you go 40 feet per second, yeah. Yeah, comparing speeds. Oh, yeah. Yeah, instead of Jeremy, I said Jason. But I think it's okay. Are we, how do we feel? Okay, let's go to number 6. Sarah walks 3 miles in 30 minutes. So now we're back to what? What are we back to in this problem? MPH. What's MPH?
Miles per hour.
All right, so we're going back to miles per hour. Draw your boxes. D equals R times T. And my two people, Sarah and Becky. Yay. What numbers do I fill in? I need miles and hours. Well, this one's easy. I already got 3 what? Miles. That's Sarah's distance. 30 minutes. What fraction of an hour? 1/2. This is R. Somebody probably could look at that and almost tell me what the rate's going to be.
That should be 6.
Nathan said it's going to be 6. Well, we'll see if he's right.
I have kind of a strategy when I do that. Instead of having to write it out, when you have it in the box, you can just do 3 by 2 if it's a 1 over a 2 or 1 over 4. You can multiply the bottom.
Exactly what I was hoping. Let's go to the next one. Becky, it'd be what? 7,040 yards. How many? It's 4. Did you check it?
Yeah.
So we some of them had checked it. So if you did 1760 times 4, 0. 2 times 4 is 4. Carry the 2. It's going to be 30. Carry the 3. 4 times 1 is 4. Add 7,000. Yep. So I agree. It is 4 miles that Becky went. She did it in 20 minutes. What fraction of an hour is 20 minutes? Yeah. Do 20 minutes compared to how many minutes? 60 minutes in an hour. Cancel your zeros top and bottom, so it reduces to 2/6, which is 1/3. So yeah, write it out on the side of your paper if you have to. Some of you are getting really good. Who can tell me what Sarah's rate is? 6. What is Becky's rate? 12. So it says, how much faster did Becky walk? 6 miles per hour faster. Okay. And we're going to stop there on the note.